Okay, viewers, moving on to Unit 3 of Pre-Calculus. So if you have a warm-up in your notes, we will not be doing the warm-up. So quickly, as I'm talking, just fill this in. This is from the video that you should have watched before this about the domain and the range of the sine, cosine, and tangent functions and their inverses. So you really just need to know that in order for the inverse to be a function, we have to restrict the domain of the function or the range of the inverse function, basically. So the restricted domain in the original function is from negative pi over 2 to pi over 2 in this dark area here for that function. And so we write the inverse function, the inverse sine function, as, and you might see it at either one of these ways. This year we'll probably see it more as, and from geometry, the sine with a -1, but you will start to see it more and more frequently written as the arc sine, and that is the exact same function. But the inverse, the domain and the range are switched. So that is why we say we restrict the range of the inverse function in order to make it a function. For the cosine, the domain is restricted in a different location because it's an even function. And if we ended up restricting, let's see if I can draw in a red. No? If I restricted here and then I rotated my screen and looked at it from the side, I would see it doesn't pass the, well, in this case, it doesn't pass the horizontal line test, which means my inverse is not a function. So to do that, I have to restrict my domain in a different way. And I'm going to restrict it from 0 to pi. That way, my inverse will be a function. So there's that. And the tangent has its domain restricted from negative pi over 2 to pi over 2. So from the left asymptote, from one asymptote to the next. And the range is from negative infinity all the way up to positive infinity. And the inverse function is switched for the domain and the range. So you need to memorize that. And that's going to come in very important because when we're doing the next types of problems, you're going to need to know how to restrict the range of your inverse function. So, like I was saying, you can write inverse functions in two different ways, with a -1 or with the arc, right? The arc sine, arc cosine, arc tangent. So the problems we've been doing up to now look like this, where we are asked to find the sine of an angle, and then we equals, and then we solve for the value. Well, we're going to be doing the opposite of that. We are now over here. We're going to be asked to find the inverse sine of a value and try to find the angle. So what happens is, and your teacher might have explained this in geometry. I usually do when I teach geometry. So if you had me, you might have seen this before, but it's been a while, right? When you are trying to do the inverse of a function, you're basically multiplying each side by the inverse. And so you've got a value here, right? And we don't know what it is. But if I essentially multiply the left side of my equation by inverse sine, I have to do the same on the right side. And what happens is the inverse sine and the sine end up canceling each other out because they undo each other because they're inverses. And what's left is the measure of the angle. So here we know that the sine of pi over 6 is 1/2 because we've memorized, hopefully, those values from the unit circle. So now we can solve for the angle if we're given the value. We just have to work backwards. So we have to think, okay, if my restricting the range here, and so if this is 0 and this is pi, right, this is pi over 2, and I'm doing sine, I have to restrict it from negative pi over 2 to pi over 2. So that only gives me 2 quadrants for the location of this angle. Sine is positive in the first quadrant, so that means it's going to be in the first quadrant. The sine, so the sine of, we look for we're given the value is 1/2. So we know that is the short side. So that's going to be a short angle because sine is the y distance. So it's the short angle, so we know it's pi over 6. And that's how we're going to do the examples. So I'm going to do 3, and then you're going to do 3, and we're going to check them. So let's move on to A, evaluate the inverse operation. First thing we're going to do is restrict our domain. We know that it has to be between pi over 2 and negative pi over 2. So the value here that we're given is positive. So we know it has to be in the first quadrant because in this fourth quadrant, the y values and the sign are negative. This is positive. It's in the first quadrant, and that's a tall angle. So I would draw that up here, and then I would think, okay, what angle is the tall angle here? That's 30, 60, 90. That's the 60-degree angle right there, which means that's pi over 3. So in other words, the sine of pi over 3 is root 3 over 2. So you're just working backwards. Let's go to B. So what angle, when evaluated for cosine, yields 0? So we need to find the angle. So first thing we're going to do is we restrict. Now, cosine is restricted differently than sine because as we were explaining, cosine is an even function. And we're only going to get the inverse to be a function if we restrict from 0 to pi. So now we're in different quadrants where the x values are positive. So we are at where is the x value 0? Right up here, so that's pi over 2. And the last one, you want to make sure that the answer is within the range of your inverse because when you restrict your range, we've got, this is 3 pi over 2, right? And we don't want to give 3 pi over 2 as our answer. That's where the sign is -1. Because 3 pi over 2 is not in our range. However, we can write negative pi over 2 because our range is from negative pi over 2 to pi over 2. So instead of writing 3 pi over 2, we're going to write negative pi over 2. So just make sure you're careful about that. Press pause, see if you can do the next 3, and I'll show you the answers. All right, so we start with the inverse sine. We restrict our range. We say, all right, this has to be a short angle. It's negative, so we're definitely in the fourth quadrant. That's going to be at 11 pi over 6, or you can think about it as negative pi over 6. We can't write this. That's not in our range. So the answer is negative pi over 6. Oop, there we go. That's 6. Okay, root 3 over 3. So hopefully you have memorized that the tangent of pi over 6 is root 3 over 3. This is negative, so we know the tangent has to be in the fourth quadrant, and the range is restricted the same as the sine. So if you know that, you know it's the short angle, and that's going to be negative pi over 6. And the last one, root 2 over 2. We know that's got to be a middle angle, and it's cosine, so it's got to be, and it's negative. That means it has to be in the second quadrant because that's where cosine is negative. Because cosine is x, and x values are negative in the second quadrant. So then we look at it and we say, all right, what angle is that? That's 3 pi over 4, so there's our answer. Now, I went pretty quickly, but if you have all those special angles memorized, it will start to get faster with time. But if you don't have them memorized, now is the time to memorize them. All right, moving on. So to find the exact value when you're given kind of a composition of functions here, a function inside the other function, you have to find the angle from inside the function first, just like we were doing. So you're going to start with what's the inverse tangent of root 3 over 3. So that's positive. We know it's in the first quadrant, and we should have memorized that's pi over 6. Now, we are going to substitute this in to this equation for the inverse tangent of root 3 over 3. So now we're just going to rewrite this. The cosecant of pi over 6. Well, that's just, you're going to think cosecant is the reciprocal of sine. So you're going to think, what's the sine of pi over 6? Sine of pi over 6 is 1/2, and the cosecant answer is just going to be the reciprocal. So you just flip 1/2, and that's 2. So there you go, done. So the next one. So the inverse sine of negative root 3 over 2. Again, that's negative. Y values are negative. So if you're restricting the range here, you know that's got to be in the fourth quadrant. That's a tall angle, boop, down there. So that's going to be negative pi over 3. So negative pi over 3. Substitute that in for the inside of my function, right? Negative pi over 3. Now we're just thinking, what's the tangent of negative pi over 3, right? And we know that is negative root 3 because we have that memorized as the tangent of pi over 3 is root 3. It's negative, so it's going to be negative. And then we just flip it. Now, when we flip negative root 3, what we get is negative 1 over root 3. We have to rationalize the denominator. And once you do this about 10 times, you're going to remember it. You won't have to do this anymore. So it's negative root 3 over 3. So it's negative root 3 over 3. Okay. Now, the last type of problem are problems that are not on the unit circle. You don't have a value that's on the unit circle. The last problems we did, root 3 over 3, root 3 over 2, those were values on the unit circle. This 2/3 and negative 3/5 for these two examples, A and B, they're not on the unit circle. So we're going to have to draw a triangle. I love these types of problems. We start from the inside. We're going to draw a triangle that has a cosine of 2 over 3, okay? Because we're asked to find the arc sine of 2 over 3. So that's going to be in quadrant 1. So we go ahead and draw our triangle, Pythagorean theorem it to figure out what the missing side is. And again, cosine, you have to know SOHCAHTOA for this. Cosine is the adjacent side over the hypotenuse. So that's where the 2 and the 3 go in those places. We Pythagorean theorem it, solve for b, and we get root 5. Now, all we're going to do is find the tangent using that triangle. The tangent using SOHCAHTOA is the opposite over adjacent, or you could think of it as y over x. So from this angle, opposite is root 5 over adjacent is 2. For B, when you draw your triangle, you're drawing a triangle with the sine of negative 3/5. When the sign is negative, it's got to be, and again, we're doing inverse, so you have to restrict the range. It's going to have to be in the fourth quadrant. The hardest part is drawing the triangle, really. Once you get the sine is the opposite over the hypotenuse, then you Pythagorean theorem it, unless you know it's a 3, 4, 5 triangle, to find the missing side. That's a positive 4 because we're going to the right. Okay, where am I at? Okay, so now that we have the triangle, we're finding the cosine of that triangle. The cosine is the adjacent over the hypotenuse. Adjacent side is 4 over hypotenuse is 5, and that's just from geometry. So when you get problems like this and you don't know what to do, you've got to draw the triangle yourself. And drawing the triangle is the hardest part. Once you draw the triangle, then it's just using SOHCAHTOA. And in summary, if you're having trouble remembering the range of each inverse function, just remember that even odd properties and apply them every time there's a negative input. So the sine is odd, the cosine is even, and the tangent is odd. So that's why the sine and the tangent are both restricted the same way, like this, and the cosine is restricted from 0 to pi, like this, like that. All right, peace out.